Hello, my name is Hogue Levins, and I'd like to welcome you to this segment of Asbestos Safety Workshop. This is a series of programs in which we discuss the latest tools and technologies of the asbestos abatement industry. Today, we're going to be talking about the process of abating asbestos hazards in buildings. Asbestos abatement involves very serious health, legal, and financial questions for all parties involved. No one should attempt to plan or carry out an asbestos abatement project in a building without a thorough knowledge of what he or she is getting into. Asbestos is found in thousands of different products and applications inside buildings. This includes schools and other educational institutions, high-rise office complexes, shopping malls, hospitals, industrial plants, government offices, and public facilities, large and small. There is no specific kind of building which contains asbestos. Unfortunately, asbestos was installed in virtually every kind of building. Generally speaking, asbestos is most frequently found in buildings which were constructed between the late 1920s and the early 1970s, when the material was banned. However, those aren't hard and fast dates. Some contractors continued to use asbestos materials in buildings after the ban, and many older buildings which date to the turn of the century had asbestos installed in them during later renovations. Let's look at some typical forms of asbestos construction materials found in American buildings. Asbestos was widely used for ceilings. One of the most common forms of general ceiling construction in the post-World War II period was suspended ceilings. For these, wire lath was strung and then covered with a concrete-like material known as brown coat. This rough textured brown coat was then sprayed or troweled with asbestos, which is represented by the yellow in this illustration. In areas of damage or repairs, the three layers of wire, brown coat, and asbestos surfaces can often be clearly seen in buildings. In other cases, no brown coat was used and the asbestos materials were sprayed directly onto the wire lath. Asbestos coatings were also routinely applied to a variety of precast concrete and concrete slab forms inside schools, offices, industrial complex, and government buildings. This is a very common type of asbestos application. Asbestos plasters were frequently used around air ducts, boilers, and other thermal equipment. Asbestos plasters were also troweled or sprayed over cinder block. Thick layers of sprayed asbestos were widely utilized in old wooden structures undergoing renovation. This type of application can often be found in barns, lofts, factories, warehouses, and other older structures modernized into office, library, store, or classroom space. Acoustical tile containing asbestos was widely installed in schools, churches, hospitals, shopping malls, and office buildings in a variety of forms. Some are glued directly onto solid ceiling surfaces, and others are hung in suspended tracks. Asbestos was used to coat steel beams in buildings of all kinds, and in some cases the beam itself was coated. In other cases, the ceiling area and the beam were both sprayed with asbestos. Bar joist constructions, which are very common throughout industry, were also heavily covered with sprayed asbestos. Steel decking, corrugated and non-corrugated, was coated with sprayed or troweled asbestos, at times as thick as an inch deep. One of the original and most common applications of asbestos in buildings involved the covering of pipes. In fact, there are millions of miles of asbestos-covered pipes in America, and they are frequently found in boiler and other rooms, which also have asbestos-sprayed beams, asbestos-plastered boilers, and tamped asbestos ceilings. Drop ceilings often hide massive amounts of asbestos materials. Prior to 1973, it was common for contractors to finish off a job by spraying the entire superstructure with thick layers of asbestos. Then they installed drop ceilings so the whole mess was out of view. It's rare that you find a single type of asbestos application in a building. Most frequently, multiple applications are the rule, with sprayed beams intermixed with splattered ductwork and utility systems and asbestos-covered pipes. Some utility spaces are virtual jungles of asbestos-covered forms. At the same time, many things which look like they could contain asbestos don't contain asbestos. Asbestos has no unique look in construction materials. It was used interchangeably with fiberglass and rock wool in such things as insulation and pipe coverings and ceiling sprays. Many pipe coverings contain as much as 80% asbestos, and many other types of pipe coverings which look exactly the same contain no asbestos. Many ceiling sprays contain up to 40 or 50% asbestos, and yet other ceiling sprays which look precisely the same contain no asbestos. Paul Getz, architect from Ardmore, Pennsylvania.
I can remember a case 2 years ago where a school district had put into their capital budget $100,000 to remove the asbestos from the corridor lobby ceilings. Eventually, they did call us to do asbestos research on the buildings in their district, and in this particular instance, where the $100,000 had already been programmed for expenditure that following June, we proved to the owner by the research we did and the laboratory methodology we did that there was no asbestos in the material they were going to spend $100,000 to remove.
So if you think you have an asbestos problem in your building, the first thing you need to do is to be sure that a problem exists at all. You need to perform the kinds of tests which will document the extent, if any, of the asbestos conditions in your building. This testing process is an involved one, which is the subject of another asbestos safety workshop program entitled Testing Buildings for Asbestos Hazards. If you're normal, the first thing you're going to do when you suspect you might have an asbestos problem is look for some quick, cheap, quiet solution, such as that which appears to be offered by the process known as encapsulation. Encapsulation has been recommended by the U.S. Environmental Protection Agency since the 1970s, and it refers to the process of spraying, rolling, or brushing asbestos surfaces with a paint-like sealer. This sealant, or encapsulant, is supposed to prevent the release of asbestos fibers into the air, and on its face, it's a pretty neat idea. The top half of this sample is bare asbestos sealing material. The bottom half is coated with a cream-colored encapsulant. Encapsulants come in both clear and colored varieties. Two types of encapsulants are currently being sold. The first is called a penetrating encapsulant because it penetrates a short distance into the surface of the asbestos material and hardens to form a crust. The second type is called a membrane or bridging encapsulant because it lays on the exterior surface like a membrane. However, widespread problems have been encountered with encapsulants across the country. Anthony Natal, the president of Dual Asbestos Removal Corporation and co-author of the industry reference book Asbestos Removal and Control, has broad experience with every aspect of asbestos control, including encapsulation. He explains,
80% of the encapsulants that we've applied have failed. You got to understand too that when an encapsulation job fails, everyone is trying to cover their liabilities. So there's very little notoriety on the material that's failed. The architect is protecting himself, the owner is protecting himself, and no one makes this public. Some of the jobs that seem to work, these jobs then are publicized, and everyone looks at this material as that it may solve their problem cheaply. It is not a cheap fix. Number one, to put this stuff on properly, you'll probably spend as much as a removal job. The same conditions exist, the same exposures exist to the people. If you look at the actual application of the materials, there's many problems brought on there. There's a lot of encapsulants out on the market. Each manufacturer is claiming miracle results if you use their product, but in fact most of these materials are just existing materials that put new names on. Some of the newer materials that have come out could be very hazardous. We've had instances where we've had severe eye burns, nervous disorders, Some of the amines that were used caused a lot of health problems. We stopped using encapsulants for a number of reasons, and that was one of the main reasons.
In Trenton, the capital of New Jersey, officials have had more experience with encapsulation than any other state because New Jersey is where the asbestos abatement industry began in 1976. William Weisgarber, a Treasury Department asbestos official, recounts New Jersey's experience with encapsulants.
Initially, in 1977, when asbestos abatements were first taking place, encapsulants were tried. In some of the selected areas where they were tried, they were used on very soft, friable, and fluffy material. Subsequent to that, the encapsulation process didn't work. It added extra weight to the asbestos material, and the material came down. I think the biggest problem with encapsulation is that once the material is encapsulated, you still have to maintain the building. You still have to treat the building. It still contains asbestos. Will there be any planned renovations to the building where you're going to be cutting into the encapsulation material? Whether or not you're simply changing things like as light bulbs, you're going to be disturbing the encapsulated asbestos. Those type of things have to be considered if you planned an encapsulation process. Specifically, I wouldn't recommend an encapsulation process unless the material was in such a state that it was very inaccessible and that removal was not feasible, and that's in very few instances.
This is what happens when encapsulation fails. The encapsulating material adds significant amounts of weight to asbestos ceiling coverings which have poor load-bearing capabilities. Sprayed-on sound and fireproofing were never meant to hold weight, and when you add weight, it causes sections of the surfaces to sag, delaminate, and ultimately collapse. This releases massive amounts of contamination. Let's look at some real-life examples. This is an asbestos ceiling in a large school complex which was coated with a clear encapsulant. Shortly after the encapsulant was applied, portions of the ceiling surface began to bulge and then fall off. This greatly increased the airborne contamination problem that the encapsulation was supposed to have solved. In such situations, asbestos abatement contractors may then attempt to patch the holes in the asbestos surface and paint over the whole mess, which will continue to delaminate and fall off in random patches in the future. Ultimately, building owners end up paying for encapsulation and then paying again for the total asbestos removal project they tried to avoid in the first place. Here's another example, a different kind of asbestos ceiling which was sprayed with another typical encapsulant. A few months after the job was completed and the building was reoccupied, the ceiling surface began to delaminate and fall off, creating a contamination emergency. In 1984, the respected national journal Chemical Week reported widespread encapsulation problems in industry and warned of another serious physical drawback caused by the use of encapsulation that can leave building owners with an even worse asbestos exposure problem than the one they started with. Many of the containment products on the market effectively destroy a building's breathability. Although they seem solid to the eye, ceiling materials actually breathe constantly, allowing the passage of substantial amounts of air and moisture back and forth. In this manner, temperature and moisture differences can dissipate themselves. However, when an encapsulating sealant is sprayed on the ceiling surface, it forms a water and airtight barrier. On one side of this barrier, the atmosphere is frequently air-conditioned and cool. On the other side, it's warm and humid, a situation which results in water condensation and water buildup on the top surface of the ceiling and throughout the layer of asbestos material. Because of the vast square footages involved, this can ultimately result in flooding and other severe water damage to the structure as well as to the utility systems. At the same time, the moisture buildup accelerates the deterioration of the organic binders in the asbestos ceiling materials, and it also increases the weight of the asbestos materials, and ultimately, this results in delamination and collapse. Another negative aspect of encapsulation concerns real estate value. Buildings which contain substantial quantities of encapsulated asbestos can be worth considerably less than the same buildings without asbestos. For one thing, encapsulated asbestos poses a long-term potential threat and a potential financial liability for whoever owns the building. Normal deterioration, along with accidents, renovation, water damage, or vandalism, can all result in building-wide contamination at a future date. For another thing, the cost of maintaining a large structure with encapsulated asbestos is higher than the cost of maintaining the same building without asbestos. And thirdly, federal law requires that before a building can be torn down, its asbestos must be removed. This can make the ultimate demolition of the building astronomically expensive. The removal of encapsulated asbestos is a very complicated and very costly undertaking. And all these factors significantly affect the long-term real estate value of the structure. Clearly, the only sensible way to eliminate an asbestos contamination problem from a building is by removing the source of the problem, the asbestos. But asbestos removal is a very involved procedure, and every building presents a very unique type of project. Right now, what we're going to do is take you through step by step the general procedures and the general principles for asbestos removal. Obviously, in actual practice, every structure has to be approached in terms of its own unique situation. And no matter what kind of structure you're dealing with, you start by acquiring the proper permits and notifications. Chip D'Angelo, head of the environmental consulting and engineering firm of Castellan and D'Angelo of Haddon Heights, New Jersey, explains.
All asbestos removal and abatement projects fall under the auspices of an EPA regulation which mandates a 10-day notification to the local EPA office of the National Emission Standards of Hazardous Air Pollutants. Therefore, it's important that the contractor provide this written 10-day notification form to the local EPA office. EPA regulates the specific information required in that submittal, and that piece of documentation is the first to be examined and retained by the owner. The work should not begin until that piece of information is in place. Other important permits are governed by the independent and individual states, local municipalities, or other regulatory agencies. Now in New Jersey, there are regulations which require that a construction permit be issued prior to every asbestos abatement project. Other states require similar notifications to local safety organizations. Recently, EPA and OSHA have entered into an agreement where the notification form is shared with the local OSHA office. This piece of information, notifications, proper permits should all be in place before the work begins.
All asbestos abatement projects begin and end with air tests. In fact, air tests are one of the single most important factors throughout an asbestos abatement project. Keep in mind that the reason that asbestos in buildings is dangerous is because the asbestos becomes airborne. And keep in mind that the concern over the diseases which are being caused by asbestos across the country is a concern focused exclusively on airborne asbestos. And the reason that a building owner spends hundreds of thousands or even millions of dollars to clear asbestos from his structure is to ensure that the air in that structure is ultimately safe to breathe. And so, documenting the exact air quality conditions before, during, and after an asbestos abatement project is crucial for all parties concerned. Dr. Roy Anderson, head of Comprehensive Chemical Consulting in Newtown Square, Pennsylvania.
While work is going on, the air tests are extremely important to prove that no asbestos fibers have been released to the building and that the contractor has successfully contained all the asbestos within the work area. That's point one. Point two is, has the contractor provided the proper equipment for his employees inside the work area? Therefore, air tests inside the work area and the personnel samples that are required to be done on the workforce inside doing the removal job are extremely important, because the contractor must be able to demonstrate that the protective equipment that has been used is capable of protecting the workforce from the exposures existing inside the work area. This comes back to the building owner's liability, even for the contractor's personnel who are doing the work.
To conduct air tests, special pumps and filter cassettes are used to pull precise amounts of air through a very dense membrane filtration material. These membrane filters are then analyzed in the laboratory by electron microscope to determine how many asbestos fibers are floating in the air. The manner in which the results of these tests are handled is very important. Chip D'Angelo.
Every air sample, its location, the date and time must be recorded. This recording is usually done by the industrial hygiene consultant or the testing laboratory on site, but must be transmitted to the owner as permanent record keeping. This will then provide documentation that the work was conducted with no adverse impact on air quality outside of the isolation zone. And again, these records and this data should be filed in the job file as permanent record. In a large job, the number of samples and the data can get very large and should be turned over to the owner even in a handwritten form on a daily basis. At the completion of the project, this should be compiled and should be formalized with a statement by the industrial hygiene consultant as to the accuracy of the sampling protocols and to the accuracy of the analytical techniques used.
These are the general types of air tests which are conducted throughout an abatement project. The interior pre-test, the exterior pre-test, daily air monitoring tests, personnel air tests, and the final or clearance air tests. The interior pre-test is an air sample or series of air samples which are collected inside the building before any work is done. The exterior pre-test is taken out here in the parking lot or at some other convenient site around the outside of the building. Now, this may seem a little odd when you first hear it, but this is a very important benchmark test. What we would do is run an extension cord into the building to power up the pump and collect some of this exterior air and analyze it to see how much asbestos it contains. Now, the air in most urban areas contains significant levels of asbestos, and the importance of knowing what the level right here is will become obvious as we get later on in this project. For right now, it's pretty easy to understand that theoretically, the cleanest we can ever hope to get the air inside that building is as clean as the air outside the building, which will constantly rush in when the building is in use. And we need to know that number. Here, inside the building, after the barriers have been erected and abatement work has started, the contractor should take 2 rounds of air samples each day. Air samples should be collected inside the work area, and another set should be collected here out in the clean area of the building. These are sometimes called station samples because the air pump is always placed in the same spot or station. And this process is also called air monitoring. This information is important in several ways. For instance, it shows if unacceptably high levels of contamination are being created inside the work area, and that would mean that the contractor would have to take action to lower the levels. It also shows if contamination is leaking out here into the clean area of a building. Keep in mind that airborne asbestos contamination is totally invisible to the human eye, and it behaves like a gas. Once it's escaped from those barriers, it leaks out here and rapidly disperses and moves down to the floor below and the floor above. It gets into the air handling systems and then moves throughout the entire building. It's possible for an asbestos abatement project in a small portion of a 30-story building to ultimately contaminate the airspace of that entire building. And that's why daily air monitoring is crucial to policing a project. Along with the high-volume station samples taken daily at the site, contractors must also take personnel samples, air samples collected with small battery-powered pumps which are worn by the laborers as they work. This provides a precise documentation of the levels of contamination to which workers are being exposed. Final or clearance tests are the most important part of the entire project, and this is when you collect the final air sample after the contractor claims to be finished with a total decontamination of the space. This test shows whether or not the contractor successfully decontaminated the building and whether the air is safe to breathe. If this test documents unacceptable air conditions, then the contractor must begin re-cleaning the air and structural surfaces. A contractor is not released from his contract until the final air tests show he has successfully cleared the building of asbestos contamination. A great deal of study and pre-planning must go into an asbestos abatement undertaking. For instance, asbestos removal is frequently carried out in phases in a building. One reason for this is that the maximum manageable size for an asbestos removal site is about 10,000 square feet. In large building complexes, it's normal to have as many as a dozen or more phases in an abatement project. Each building section is totally cleared of asbestos and decontaminated before the next phase begins. Another reason for doing a removal in phases or sections is to allow the rest of the building to remain in use during the project. This is particularly important in industrial or administrative facilities which cannot easily or economically be shut down. The area where asbestos removal will take place must be completely isolated from the rest of the building. All doors or other entrances into this area must be identified and posted with warning signs. The purpose of this is to warn building users that they are in an area where they could be exposed to invisible airborne asbestos contamination. Robert Twombly, co-author of the Asbestos Abatement Workers Training Manual and Vice President of Resource Management International of Media, Pennsylvania, explains.
We post the job, first of all, it's a requirement in the law to post a job where asbestos work is going on. We do a couple different things. Depending if the building is occupied or non-occupied, we would do a different type of posting. If a building is occupied, you want to take extra care in making sure that someone accidentally doesn't walk through a plastic barrier or come through a door that is in an active work area. In those situations, we use critical barriers, which are actually constructed out of plywood and 2x4s in these areas, or make sure the doors are locked before they're covered with plastic. Posting still is required on these doors. We've had instances where other trades working in a building would see plastic sheeting and posted signs and still pull out a utility knife, cut the plastic, and walk through and find out what's going on. So if there's any other trades or any other people in the building that could possibly, for any reason, disregard the signs, you have to take extra care with that type of situation and make sure that you have critical barriers erected at all the proper locations.
Large trucks will be used to deliver supplies and equipment to the site, so it's important to have a well thought out plan for routing flaps by their weight. Specific doors need to be designated for the movement of equipment and supplies. Inside, staging areas should be designated for temporary storage of the substantial amounts of machinery and supplies which will be delivered to the site. A secure room should be designated for worker changing and equipment storage. Here, workers will change and leave their street clothes each day. Locked doors or lockers are essential to protect personal valuables as well as the costly and sensitive equipment which must be kept here during the project. All furnishings and fixtures will have to be removed from the workspace. This is a time-consuming, labor-intensive task. If it's performed by the contractor, it will significantly raise the cost of the project. If done by the building custodial personnel, those personnel must be warned that they are handling potentially contaminated objects and measures such as respirators and protective clothing may be required. The furnishings and fixtures themselves may require decontamination. Rugs are virtually impossible to decontaminate and in most cases are best discarded. Persons ripping up rugs should be provided with full respiratory protection because rugs electrostatically attract and hold large amounts of asbestos contamination. Rug removal releases this contamination back into the air. Areas elsewhere in the building must be designated for the temporary storage of fixtures, furniture, inventory, books, records, and other items which must be removed from the workspace. Emptying out large business or institutional office spaces can be a monumental project in its own right and should be carefully considered. During the asbestos removal project, areas which once looked like this will ultimately come to look like this. Polyethylene plays a very important role in asbestos removal. In fact, American asbestos abatement contractors use so much of this material that they're one of the world's largest markets for polyethylene sheeting. Normally, contractors buy polyethylene by the ton. It comes in two thicknesses, 6 mil and 4 mil. And a mil is a unit of measurement of 1/1000th of an inch. And 6 mil refers to the thickness. Normally, 6 mil is used to put on the floor because it protects more against the grating of shoes. 4 mil, on the other hand, is most frequently hung on the wall because it's lighter, and weight plays a large role in how well a polyethylene sheeting will stay adhered to the wall with tape. To prepare a space for asbestos removal, the entire space must be covered and sealed off with polyethylene. First, all floors are covered with 6 mil poly. All seams across the floor are sealed with duct tape, and the polyethylene is brought a short distance up the wall and secured there with duct tape. Then, 4 mil polyethylene is used to cover every wall surface. The polyethylene is duct taped at the top of the wall so that the only portion of the room which will be exposed is the asbestos surfaced ceiling. Some wall surfaces don't take duct tape very well and require that wooden strips be temporarily installed to hold up the poly. Various kinds of spray adhesives are also used to firmly anchor the sheeting to the wall surfaces, which are resistant to duct tape. Light fixtures must either be removed from the space or sealed with polyethylene. All radiators, vents, and other air-moving openings must be sealed off. Stationary machinery, equipment, or other items which cannot be removed from the space are covered with 6 mil polyethylene. Corridors are completely covered. Stairwells are covered, but polyethylene is never put on the stair treads. This is because it's very slippery and can cause severe injuries to workmen on the site. It's often necessary to erect barrier walls to seal off part of an open space. These are built with 2x4s and 6 mil polyethylene, which is stapled and then sealed with duct tape. At times, large sheets of plywood are used to reinforce this wall. Then, all wall coverings, floor coverings, equipment coverings, and barrier walls are joined at the edges and sealed. The result is that the workspace is now a labyrinth totally sealed in plastic except for those asbestos surfaces which are to be worked on. Care has to be taken to ensure that this plastic covering is installed and maintained properly. Robert Twombly.
If plastic begins to fall down halfway through the job, that's where contractors run into problems most of the time with plastic, is it was improperly hung. The room gets hot because of workers in the room. You're using a lot of water, amended water for the removal process, and humidity affects the tape and plastic begins to fall down. Then the mistake is that the job is not stopped and the plastic rehung properly. The job, due to schedule considerations, is continued, and you've ended up possibly with a problem in contaminating walls or breaching an airtight barrier, which may release fibers into a clean area.
You'll notice that some of the men you just saw were wearing street clothes, while at other sites, men performing the same covering task were wearing protective gear. There has been a difference of opinion in the industry over the years about whether protective gear is required at this point. However, workers installing plastic, wooden slats, and duct tape at the edge of asbestos ceiling inevitably create significant amounts of asbestos contamination, which becomes airborne or attaches itself to their hair and clothing. For this reason, asbestos abatement authorities like Anthony Natal and Robert Twombly recommend respirators and protective paper suits should be worn during this covering phase. Now, the work area is totally sealed off or contained from the rest of the building's airspace. To facilitate the safe movement of workers in and out, an airlock is built. This airlock is sometimes referred to as the decontamination chamber because workers will decontaminate their bodies as they pass through it. The exact size of this airlock depends upon the size of the job and the number of the men who will be passing in and out each day. Contractors commonly use prefab airlocks. Here are the wooden skeleton forms of such an airlock. The forms are carried into the sealed work area and set up at a doorway. The wooden forms are attached with strips of wood. A shower stall is built with a metal pan to catch runoff water. The water is emptied from this pan by a standard sump pump. Because of the potential for electrocution, this pump is never operated when anyone is in the shower. The wooden forms are covered with 6mm polyethylene, which is stapled and sealed with duct tape. The unit is also sealed at the floor with duct tape. Inward moving flaps are installed on each of the 4 doorways inside the airlock, and when the special portable air handling machines called negative air filtration units are installed in the work site, these airlock flaps will open to allow a constant inward rush of fresh air. This prevents airborne contamination from moving out in the other direction through the airlock. No matter what their size or shape, airlocks all have the same general features. They consist of 3 chambers. A door at one end leads from the work area. To leave the work area, workers enter the first chamber of the airlock and discard all their clothing except for their respirators. Then, they step into the next chamber and the showers. In the shower, they wash off their respirator before removing it and then thoroughly wash off their bodies. Finally, they step into the 3rd chamber where they dry off and put on fresh paper suits. Behind them, other workers roll up a paper walkway which pulls all track debris back into the work area. The final step in the process of containing or sealing off the area is the installation of negative air filtration units. These are sophisticated machines capable of pulling huge volumes of air through very, very dense filters 1 foot thick. This air is exhausted from the work site, and thus fresh air is constantly pulled in through the flapped airlock doors. A negative air filtration system serves to prevent the escape of airborne contamination as well as other important functions. A full explanation of this complicated subject is given in a separate asbestos safety workshop program entitled Guide to Negative Air Filtration Systems at Asbestos Abatement Sites. Asbestos removal workers face extraordinarily high risk in their job, and for this reason, they must be provided with protection against the airborne asbestos which can cause cancers and other diseases throughout the organs of their bodies. The men must be dressed in protective, disposable clothing and must be provided with respirators. They must know how to inspect and test their respirators and to ensure that they're working properly. There are several different types of respirators and controversies over which type should minimally be used at asbestos abatement sites. The most effective forms of respiratory protection also tend to be the most expensive, and generally speaking, contractors would prefer to spend the minimum amount of money on such safety gear. Workers, on the other hand, frequently don't understand the differences between various types of respirators. This is a single-use or paper respirator. This is a half-face cartridge respirator. This is a full-face cartridge respirator. This is a powered positive flow air purified respirator. And this is a Type C respirator rig. Each of the respirator types you just saw offer different levels of protection to your lungs against airborne asbestos. The first type, this type, a paper or single-use respirator, offers no protection at all to your lungs against the carcinogenic effects of airborne asbestos fibers. This kind of respirator allows millions of asbestos fibers each hour to pass through. And this kind of respirator, a paper or single-use or what's sometimes called an 8710 respirator, can never ever be used in any situation where asbestos is involved. It provides no protection to your men. Any contractor who provides this kind of respirator to his men is willfully and knowingly doing those men immediate, grave, and irreparable bodily harm. If you see a contractor on a job with this kind of respirator given to his men, get rid of the contractor. If you're a building owner or a building user, you may assume that the type of respirators a contractor provides his men are of no concern to you. Well, think again. A contractor who will cut corners on so crucial an issue as his men's respirators is equally likely to cut corners on you and the procedures required to protect you against long-term invisible contamination liabilities. So remember, The type of respirator that a contractor provides to his men is often a very good barometer of the contractor's competence or real intentions. This half-face cartridge respirator is used extensively for asbestos-related work. However, in 1985, there was a growing concern among many authorities that this type of respirator may not provide adequate protection to men who work all day long in asbestos-contaminated air. This is a full-face cartridge respirator, and it's also used extensively on asbestos abatement projects. As you can see, this type of respirator rapidly fogs up and is not well liked by workmen. Half-face cartridge respirators and full-face cartridge respirators are called negative pressure respirators because in order to make them work, you have to suck in to create a suction or negative pressure inside the mask. The disadvantage of this kind of respirator is that because there's a constant suction, at any place where there is not an exactly perfect fit around the seal of the respirator, contaminated air can rush in. And given the imperfect nature of the human face and the strenuous nature of asbestos removal work, it is very difficult to maintain a perfect fit around the seals all day long. This is a powered, positive flow, air purified respirator, and the big difference with this one is that it has a battery-powered side pack worn on the belt. The power pack pumps air through HEPA cartridges and then forces that air through a hose into the facepiece, creating a positive flow. Because air is constantly being pumped into the facepiece, the mask doesn't fog up, and at the same time, if you happen to have a loose seal around the face, air will forcibly leak outward, preventing contaminated air from leaking inward. That's why positive flow provides a whole new dimension of protection, and in 1985, in its report on asbestos in respirators, the Safety Committee of the AFL-CIO headquarters in Washington recommended positive flow respirators as the minimum for asbestos work. This is a Type C rig and includes an exterior compressor which supplies air through hoses into the work site of a building. Type C rigs are expensive and complicated to operate, but they also provide the most comprehensive protection to men who must spend many hours each day inside asbestos-contaminated airspaces. The first step in the actual removal process is wetting. The asbestos surface is wet with a mixture of water and surfactant, a chemical which helps water penetrate better. If asbestos materials were removed dry, extremely high levels of asbestos contamination would be released. Keeping the materials wet minimizes the contamination levels created by the work. However, there is a delicate balance between too little and too much water. Chip D'Angelo explains.
All specifications and all EPA and OSHA guidelines specifically call for wet removal. If this is misconstrued, it can result in serious damage. We have seen contractors believe they can clean asbestos off of a surface with high pressure water, pressure washing water jets. We have never seen this successfully done. The contractor will come in with incredible volumes of water, attend to spray or blast the asbestos off. This results in incredible water buildup on the floor. If that water is not properly contained, you not only have water leaks, which result in drippings and water running to lower floors, but now this water is contaminated with asbestos. We have seen projects where this was attempted, where the water brought a portion of the asbestos down. The floor became a 2-inch deep lake and soggy mess of asbestos, which then allowed the asbestos to run laterally and get into every single wall and floor crack and crevice in the space. Now the contractor has added a substantial amount of unnecessary cleanup work. Without properly containing the asbestos as it was falling, by using much too much water, he's created streams of asbestos leaving his work site. It's a fine line between the proper use of water. The contractor needs to mist the air with an electric airless sprayer. He needs to apply water as a dust reduction agent, and he needs to apply water to the waste as it's being packaged. He does not need, and by no means should he be in there with a garden hose or a high-pressure water jet washing and flooding the space.
Getting men positioned to safely perform heavy demolition work on ceilings or the superstructure often requires substantial amounts of engineering skills and equipment. Scaffolding, hydraulic lifts, and other such items are routinely used. Asbestos removal contractors must be proficient in normal engineering skills as well as contamination control procedures. The physical process of removing asbestos material involves a variety of relatively simple tools. Hand scrapers, long-handled scrapers, chisels, hammers, wire brushes, and wrecking bars are standard. Different materials must be removed in different ways. Asbestos sprayed on brown coat can be skinned or peeled off. This type of material is widely found in schools, hospitals, offices, and public buildings. Asbestos sprayed directly on wire lath presents a very different problem. The workmen must first puncture their way through the wire lath. Then they enter the ceiling space above, and from there they use heavy metal cutting tools to cut out the wire section by section. This can be very dangerous because this sort of lath is very stringy and its cut edges are as sharp as razors. The entire ceiling structure is carefully taken apart and removed. The dismantling of this, as well as other kinds of ceilings, is a complicated process which requires considerable planning and engineering skills. Many things can go wrong if it is not done properly. Corrugated steel decking is very labor-intensive to clean because the work is done one corrugation at a time by hand. Laborers routinely must work in tightly cramped spaces high in the superstructure. There, they peel, crack, gouge, scrape, smash, and cut asbestos from steel, concrete, wood, and pipes. The job of an asbestos removal workman is as backbreaking as it is dangerous. The process of asbestos removal is also incredibly messy. The large volumes of water used and the massive amounts of debris generated during the project can turn a building space into a swamp. It's only at this stage that you begin to appreciate the real value and importance of proper polyethylene covering. Adequate, well-sealed covering prevents the spread of contamination and also protects the structure and the utility systems against water and other kinds of damage. Earlier, we explained to you that the process of removing asbestos from a building creates gargantuan amounts of airborne asbestos contamination, and we explained how you use air collection pumps to take samples, station samples. The problem with station samples is that it frequently takes a day to get the results back. So let's say that this barrier is leaking behind me, and we take a test, and by tomorrow we know that the leak occurred. Well, the leak has occurred and gone on for 24 hours. So at asbestos abatement sites, a second line of defense is used against contamination escape, and this is what it is: a fibrous aerosol monitor manufactured by the GCA Corporation of Bedford, Massachusetts. This machine contains computer circuitry and lasers and other high-tech mechanisms, and it draws in air from the space right here, runs it through its mechanisms, and it's able to find larger fibrous forms. And at the digital readout over there, it provides you with a reading of the forms it finds in fibers per cubic centimeters. So if there were 1.2 fibers per cubic centimeters in this airspace, this machine would point it out to me. There are severe limitations to a fibrous aerosol monitor. For instance, this machine can only see larger fibers of asbestos. Fibers which are smaller than 0.5 micron in diameter are invisible to the machine. And those kind of fibers happen to be the ones which are most numerous and most dangerous and the kind of airborne contamination found in sites like this. However, this machine, just being able to read the larger fibers, serves as a superb barometer to air conditions because it gives you an immediate readout. That is, when I turn it on, it pulls in air and it immediately tells me how many fibers it found. Well, that's very useful at an asbestos abatement site. In effect, we use this machine to stand constant guard duty around an asbestos abatement site. This machine is taken from location to location immediately in the clean area outside the barriers, as well as to floors above and floors below and other distant points depending on the building. By constantly monitoring the air with a fibrous aerosol monitor, we will be alerted immediately to any fiber elevation. For instance, let's say that we have the machine running and it's showing us 0 fibers per cubic centimeter in a particular area of the building. But then 5 minutes later, our technician checks it and he sees that the reading has suddenly gone up to 1.5 fibers per cubic centimeter, a very high level. Well, obviously that immediately alerts us that we have a very serious problem, and the problem is behind those barriers. Something somewhere is causing invisible airborne contamination to leak beyond the barriers and begin to disperse through this air here. Fibrous aerosol monitors are also used inside the containment barrier to take readings of air conditions during various phases of the work. This can quickly alert foremen to the fact that negative air filtration systems are not functioning properly, or these readings can also indicate that the fiber levels are rising due to some other non-obvious problems inside the work zone. I have to emphasize to you again that the fibrous aerosol monitor doesn't give you accurate readings of the full airborne fiber conditions. It only gives you a reading of the general conditions, and this is important to know because there are increasing reports that unscrupulous contractors at times are telling their clients that they don't need the other kinds of air tests because a fibrous aerosol monitor is on the job. That is totally fraudulent. Fibrous aerosol monitors can never ever be used to take the place of the other air monitoring test we described earlier in this program. Once the gross asbestos surface is removed, brushes are used to clean the finer residue. Depending on the consistency of the asbestos covering and the nature of the structural surface, various kinds of brushes are used. In the case of very smooth sealing surfaces, medium bristled brooms work well. When rough brown coat surfaces are involved, it's necessary to use wire brushes to get the remaining asbestos from the crevices of the rough texture. The gross debris is shoveled up and placed in 6 mil polyethylene bags or cardboard drums. The drums are used when the material being removed contains cut wire, wood, or other debris which could easily puncture polyethylene. The drums are first lined with a 6 mil polyethylene bag, filled and then sealed with a lid. All debris leaves the work site through a special airlock built for this purpose. Each bag or drum is first wiped off and then handed through the first door of the airlock. As it's received in that airlock chamber, it is placed in another clean 6 mil polyethylene bag. This bag is sealed and then passed through to the next airlock door. From there, it goes into a truck or dumpster, and great care must be taken to ensure that these receptacles are secure. Dr. Roy Anderson.
An open dumpster on a school playground is an invitation to disaster. The dumpsters must be locked, and they must be made as inaccessible as possible to curious children.
Brooms are then used to sweep up as much of the remaining debris as possible. Then, special HEPA vacuums are used to vacuum the surfaces. These vacuum cleaners don't spread contamination because they're equipped with special exhaust heads fitted with extremely high-density filters which trap and hold asbestos fibers. In the case of ceilings and other concrete-like structures, the surface is then rolled, brushed, or sprayed with a covering of paint. Later, after asbestos removal operations have been completed, normal construction crews can apply new sound or fireproofing materials. However, before paint or any other material is ultimately sprayed on, certain precautions are necessary. Dr. Anderson.
One of the obligations that a building owner has is to be sure that a complete removal has been done in the areas that have been worked on. An awful lot of contractors, an awful lot of unscrupulous consultants will go ahead and respray over an incomplete removal job, for example on a ceiling, so that what the building owner is left with is asbestos material that has not been removed, particularly at the joints of the ceiling and walls and in the corners, and that's covered by respray material, whatever that respray material happens to be. If there's water damage years later and a section of the ceiling falls away, then the asbestos is exposed again, and the liability and the chance for injury is extremely high.
Workers then begin very carefully to remove the covering or polyethylene sheeting. The goal of this is to handle the covering in a manner which ensures that all adhered debris is rolled inward and trapped. In most situations, Uncovering starts with the walls and then the floors. Each is folded in upon itself and rolled into a tight ball, which is then placed in a 6 mil polyethylene bag. This bag is then handled the same as other asbestos waste at the site. When the walls and floors have been uncovered, the HEPA vacuums are then used to vacuum all surface areas. Closets, molding, light fixtures, window panes, as well as the floor and other surfaces are thoroughly vacuumed until all visible residual asbestos dust is gone. Then, the only asbestos which remains are the millions of invisible fibers which are floating in the air or lightly adhered to room surfaces by electrostatic forces. The final stage of cleanup is aimed at these fibers and involves mopping, wiping, and aggressive decontamination of the air within the space. The mopping operation is fairly straightforward. Floor surfaces are thoroughly mopped and remopped. Workers then use dampened disposable towels and begin a systematic wipe down of every horizontal and vertical surface. This wipe down is carefully planned, and the work crews always work towards the negative air filtration units. This ensures that fibers which are sent aloft by wiping do not circle back behind the men. Instead, they are pulled toward the negative air unit, which ultimately traps them. In this manner, both the structural surfaces and the air are ultimately cleared of the remaining asbestos contamination. At this point, this is the situation in the building. All the perimeter seals remain intact. The entire area remains completely isolated from the rest of the building's airspace, and the area is now ready for the final inspection and final air test. This test is called the final or building clearance air test. An air collection pump is brought in and used to collect at least 200 liters of air through a 37mm filter cassette. This will then be analyzed at the lab, and the results will determine whether or not the contractor is released and the building is reopened for use. In the industry, this final or clearance test is considered to be the single most important event of the entire abatement project. Authorities place great emphasis on the need to have this final air filter analyzed by electron microscope. Anthony Natal.
Well, if I were a building owner, I would be looking at my whole intent of why I'm spending all this money to remove the asbestos. When you have a health hazard. To remove that health hazard, you have to be able to test adequately and have an instrument that will be able to, in fact, tell you whether that building is clean at the conclusion of the job. If this is not accomplished, what you've done is spent a lot of money, added contaminants to the air, put your people in that building in a hazardous situation and exposed them to asbestos fibers, and once exposed, you can't erase that fact. So it becomes very, very important that the testing methods utilized are adequate to determine whether you in fact have a clean building when the contractor has left.
Perhaps the single most troublesome aspect of an asbestos abatement job is the tons of dangerous debris which can be created by the work. Truckloads of this stuff must be taken away and permanently disposed of, and both government officials and private authorities throughout the asbestos control field acknowledge that waste disposal is a major and complicated problem.
Our experience has been that it's an extremely difficult process to dispose of asbestos. Some places treat it as hazardous waste, some places treat it as industrial waste. It becomes more difficult when you transport it across state lines. And the building owner's concern is this, is that until that material is properly packaged and disposed of, the responsibility still lies, in a sense, with that building manager, building official, or what have you, in ensuring that the material is properly transported, labeled, packaged, and disposed of. Because if it's not, the building owner is going to be eventually dragged into some case later on down where this was material from your building and it was not disposed of properly.
Yes, the building owner should be concerned. I can't stress enough that he is responsible for his waste. The contractor doesn't assume responsibility for the actual physical asbestos that's removed from the building. If something happens, any lawsuit, the building owner would also be named in it. So he can't take this lightly and say that he's hired someone to take care of it and wash his hands of the whole thing. dump situation for asbestos has gotten worse over the past couple years. We've seen disposal costs double and triple in some cases at these approved sites. This should be one of the things that the building owner is concerned about, to make sure that the proper landfill has been selected for the disposal of his waste.
As dump prices continue to rise, unscrupulous contractors can be motivated to jettison this asbestos debris in fields, wooded areas, along deserted roads, or other similar places. This practice obviously threatens the community at large. At the same time, it ultimately exposes the building owner to potentially catastrophic legal and financial difficulties. Some states are now experimenting with the idea of having all debris bags and drums serial numbered so that they can always be identified. So, if you undertake an asbestos abatement project in your building, the trail of the waste is something you have to keep a very careful eye on. And that's going to about wrap it up today for Asbestos Safety Workshop. We'd like to thank you for being with us, and we hope you come away from the program understanding the process of asbestos abatement a little better. And we also hope you'll join us on our next segment. Thank you.